Okay, yeah. Do you know what is the coverage ratio of this area? Okay, let's assume it's 60%. Okay, then we can show, we can use a formula to calculate, so we know how much is. I would use this text. I mean, I don't use slider in this case because you may accidentally slide it. Okay, so, and then here you have, and in many cases I also prefer to do it this way. Instead of using this component to do the multiplication, okay? Because I mean this is clear. When you see it, then this is clear. So you know that this is, how come it's so slow? Okay, this is the buildable area ratio, okay? So if we come up with the idea that we want to have a large retail space on the ground and maybe also the second floor, okay? So we just okay, and of course we also need to know the setback, so maybe we can take an offset. Assume that the setback as maybe 4 meters. Okay, for all that direction. Okay, of course in reality it's not like that, but we just assume. Okay, then we know that we have to make a volume like a podium within this area. So you can draw whatever you want. I shouldn't do it this way. Okay. Or let me simply use a new drawing. I mean, because this AutoCAD drawing is simply takes a lot of memory. So I think okay, use meters, large object. Okay, you can use Rhino lines, or you can also use grasshopper. Set multiple point, and then we may be, I mean, you are a designer, so you may think, oh, this is good to have a building like this. Okay, like this. Okay, and then we make a polyline. Oh, sorry. Set true to close it. Okay, but of course we don't know if this is too large or too small. Then we can check it automatically. So what can you do? This is A, and then we also need to check the area of it. this is for Y. And this time it should be Y divided by X. And then we check if it is smaller than 0.6. Okay, so it is too small, right? So we can make a larger building if we want to maximize. Okay, so maybe we can move it. Okay, so so it's just like a dashboard. How come it is not? Oh, yeah. Wow. So I think we can cover the entire area. It's because we have the setback, okay? But you still cannot violate the setback, right? So maybe it is not possible to make to full use of this coverage ratio. Okay, it can be. Okay, and assume this is the podium, and then we can convert it into a surface. How come it is so slow? And then we extrude it. With the Z vector. And then we use a formula because, with our Lego building, we have 3.2 meters per story, right? We have our Lego block. The height is 80 centimeter. So with 4 layers, we make up one floor. Okay, so it's 3.2. Or if you want to have higher floor, maybe, but at this moment, we don't know that much detail yet. Okay, so we simply assume that the story height here is 3.2, and then the X will specify how many floors. So like it's 2. And again, X multiply Y, and this is the height. This is the site. Okay, so this is the podium. Okay, and now we can make a higher, or maybe you can check it. Okay, maybe like this. You make it 3 or 4. Okay. Okay, and then we go back to the top. Okay, then we can decide we make our office building. Then maybe say do it this way. Okay, make it facing the largest road, or maybe we put it back a little bit. Okay, something like this. Okay, and then we reference to, I mean, there are different ways of doing this. Okay, so I just do it this way. And first, it has to be on top of this podium, right? So we have to transform it using this vector. Okay, and then we are going to decide how to extrude it. Oh, we need to make it a surface again. And then to extrude it, okay, for example, we want to make it 10 stories. Then this is our building mass. Okay, and maybe you want to show of them, and maybe you also want to show the surrounding buildings. So you, okay. Now you can see how does it look on the site. Okay. Oh, of course we need to remove this existing building. Okay. Okay. Maybe you have to check it and then remove them. Okay. Then we can see it more clearer. Okay. And of course we have to check the volume of it. So what we can do is, I would like to use volume to do this. Okay. What can we do? Union. What time is it? Okay. We union it into, okay, sometimes we do subtraction. Okay. For example, we want to edit our building mass, and you want to have some places concave or indented, then you use subtraction. Not always, or you want to make an atrium, then you subtract the volume, okay, from it, and then you get the total volume. You calculate the volume of it, and then divide it by the floor height. Then you get the floor area. Okay. So we go to mass. Oh no, X. Okay, then this time you also has to calculate another one. This is the floor area, and also compared to the area of the site, which is this one. Then you get a percentage. Four, this is too large. So we have to reduce our building volume. Okay, so maybe we make the podium one floor less. Okay, then the building become like this. Right now it's 3.6. Okay, assuming that our allowance is 3.5, so that's 350%. Then maybe we think about also reduce one story from your office building. Okay, so now it's 3.39. Okay, so what you need to do. Okay, this is the total building mass, but this building is separated into two parts. Okay, one part has a property. Okay, so this is, we want to make our building information model. So not only the geometry, but we also need to specify some non-geometrical information. And of course, this is important. The bottom part is retail, and the top part is office space. Okay, so maybe we don't want to have only this union volume, but we kind of have this two volume separated. Okay, and then we can assign. Okay, they are in different way. I mean, depending on how we want to organize this information, or maybe like we associate this with another list. So the first one is retail. Oh, sorry. Okay, and then actually like we can reorganize this data. We say tree and then merge. So we merge these two lists. But then when we merge it, you graph it. Then you can see that it is organized in a tree, as a tree. And then, okay, first you know the geometry, and then you know the function. Okay, and this is only at the beginning because right now it's so simple. Okay, but then we can gradually organize our information. Okay, I'm using this just to, I mean, because you haven't taken the course of data structure in computer science, right? Maybe some of you did, but most of you. Okay, so you need to know how to organize your data so that you can access the information that you want in later processes. Okay. So actually, the program like Rabbit is done this way. Okay. So right now, using Grasshopper, we get into the more bottom level of programs like Rabbit. Okay. And I think this is important because if you gain experience in this, you know more about design information system. Okay. Then next time when you use Rabbit, you can see by guessing and by some kind of analysis, you know what is happening inside this program. Okay? You get to know the fundamental operations of this kind of program. And another purpose is that actually if you know this, then you can make use of almost any modeling tool and then to do building information modeling. Okay? You are no longer limited to tools like Rabbit. You can use Rhino, you can use SketchUp, you can use AutoCAD to do BIM. Okay. Okay, so you get it? So now we can calculate how much floor area for retail, how much floor area for office building. Okay, and if you go on, you can also estimate, for example, like you may need to have 20% of circulation. So for retail spaces, this 20, or if it is more luxury or more high quality, maybe you take 25%, and then this 25% of area is not for rent. You cannot rent it because it's circulation. And also for office building, you need to have like the service core, you need to have elevator, and especially when this is a high-rise building, then you know that the service core, the area that it takes for the elevator is much more than if this is a low-rise building. Okay, so you can do better and better estimation for your client. Okay, and if you organize all the data in a way which can be very efficiently retrieve or access the information that you need, then it's building information model. Okay? If you didn't organize your data, you simply want to make the drawing and then when you look pretty, then you think it's fine, then it's not building information modeling. So it's not a matter which software you use. I mean, you can use Rabbit in such a bad way so that you cannot access the information that you need. Then you are using Rabbit, but it's not building information modeling. Okay, or building information management. Okay? But if you are using it in a smart way, it doesn't matter which tool that you use. You can use AutoCAD, very early version AutoCAD. You can organize your data, your drawing in layers, and you make this layer so meaningful, and then the way you draw it, not only the way you name your layers, but also the way you draw it. For example, if you draw your street in a nice way so that you can use that directly as the traffic network, and then you can use it to do a shortest path analysis. Okay? Then that's information modeling or information management. Okay, if you only care about the boundary of the draw and then you didn't connect all the lines, but I mean, they look connected, but they're not, or I mean you separate them into fragmented curves, then program cannot help you, and it's not information modeling. Okay, so I want you to start to, I mean, you have already got your team, Okay, so you can start to think about the site plan, okay, and to think about how you are going to make load 100 model for your site plan. Okay, maybe next week we can start to try using Visual ARQ for your load 100 model. Okay, so far I am not very comfortable using Visual ARQ to build 100 model because apparently it is not meant for that. I think it's more adequate for low 200 model, okay, Visual ARQ. But I would try, okay, and to see if we can use that for it. Okay.
Okay.
Questions? Okay, and think about the project, okay? And Felicia asked me what happened if more than 2 teams choose the same site. For example, like if all teams think this triangular site is more interesting, so all the 16 want to do that. I don't want that to happen, right? We have 2, 2, 2, right? So I would suggest we bid for that. You have developer in your team, right? So as an architect, you have to help your developer, and also you have consultant, right? And this consultant might be the market consultant, okay? So you have to estimate the value of every land, and then you bid for it, okay? If you don't win the bid, then you cannot do the project because you don't have the land, okay? And if you don't get any land through the bidding, then you have to take whatever is left over. Okay? And if you win more than one land, okay, let's think. Well, then what we can do? I mean, for example, all the 3 land are bought by one team. Well, okay, then maybe you can subcontract to another group. Okay? But then you take the responsibility. Okay? But then you have to pay the other group for handling the project for you. Okay, let's think about what to do then. Okay? And yeah, then in that case, we need to make this evaluation to a ready next week. So next week, each team, you can try to use that to help you to evaluate, to estimate the value of each land. Okay, and yeah, the 2 teams which has the highest price, bidding price for the land, will get the land for your project. Okay, and if you are far behind, then you have to take whatever is left over. Okay. Okay. But of course, I mean, any of this is okay. But it's a matter of your dignity or your pride. Okay. If you don't get anything, then well. Okay. Okay, so Kevin, Zhongwei, and Jiayang. Okay, we have to make sure that this week we have to come up with all this evaluation, okay, program for retail, for office, and for the facade. What else do you think we have to measure? Okay, anyway, if you think of something, then let me know. Okay, so that's it for today. Okay.